Okay, everyone, good evening.
Yes, good evening.
All right, let's remember the rules. One, we're going to turn our cameras off. You're going to keep your background as quiet as is possible. And you're going to wear headphones if you have them so that we don't have a feedback loop going. All right, so let's start with these questions that are here.
Sir, I don't have a headphone, sir.
All right, well, try your best to turn it down as best you can so that we don't keep hearing the same thing over and over. All right, let's look at number one. In number one, we have 2000 and what?
2045, sir.
Plus 1000 plus 1239 plus 846. Let's see if we can work this out. So are we there already? So let's go. So it will be 9 and 5 would give us what? 9 and 5?
9 and 5. 14, sir.
14 and 6. 14 and 6.
15, 16, 17, 18, 19, 20, 20, 20, sir.
So it will be 20. We're going to write 0 and carry 2. So 2 and 4 would be what?
5, 6, sir.
Okay, so 6 and 3.
9.
9 and 4 will give us what?
10, 12, 13. 13, sir.
13. So we're going to write 3 and carry the 1. So the 1 and 0, still 1. 1 and 2, 3. 3 and 8 would give us what?
11, sir.
11. So we write 1 and carry 1. All of this would add up to what?
Okay. 4, 3. No, 4.
4.
4.
Our answer would be what?
430.
4,130. So 2045 plus 1239 plus 846 is equal to 4,130. Okay, let's look at this. This question is a sequencing question. All right. So if we have 9, then we have 18, then 27, then 36. Something is missing, then 54. What is the missing number? Somebody's background has a truck passing there. You have to turn it down or mute your background, please.
Sir.
Okay, who's answering? I haven't identified that. Who's answering?
Sandre Salman, sir.
Okay. All right, so you say it's 45. How you know it's 45?
Sir, sir, I just sir added how much it would get from the 18 to 27, then to 27 to 30, then to 36 to 45.
Okay. And how many are they adding each time?
9.
Okay. So this is the same as 9 times 1, 9. This is 9 times 2, 18. 9 times 3, 27. 9 times what? 4, 36. And what? 9 times 5, 45. And 9 times 6, 54. Remember that multiplication is repeated addition. Okay? So in this sequence, when we have a sequence, there's a pattern and a rule that we have to look for. Okay? So here it is that they were multiplying or giving the multiples of 9, the first couple multiples of 9, or they're adding what? 9 each time. So 9 and 9, 9 plus 9 would give you 18. 18 plus 9 would give you 27.
27.
27 plus 9 would give you 36. So 36 plus 9 would give you 45. And 45 plus 9 would give you the 54. Understood that? Understand that?
Yes, sir.
Is that understood?
Yes, sir.
All right, cool. All right, so let's go now. Next one we have
Sir,
Paul. Paul
excuse
has
me, sir. What are is the maths book you're doing this from, sir?
no, just some questions that somebody gave me to work out.
Okay, sir.
So Paul has P number of cards. Dale has 35. Which operation, right, is needed to show all the cards they have together? Which operation?
Addition, sir.
Why you say addition?
Sir, because
why is not
sir,
division?
all, sir. I
Let's look at this word, together. When we are dividing, we are doing what? Separating things. When we are multiplying, repeated addition. Subtraction, we're taking away, we're going to get less. And division is really repeated subtraction. So our answer is addition. Clear?
sir.
Clear?
Yes, sir.
Here we have a question. 3 3/5 plus 4 1/2. I'll give you a minute to try it and then we'll work it out together.
Uh, sir, four over seven, sir. 4/7, and the whole number is 7, sir. Four whole number 7 and 4/7.
All right, let's look at that and see if that is so. We have two ways we can work it out. We can deal with the whole numbers first. So we have 3 plus the 4, that would be equal to what? 7.
7.
Then we have the 3/5 plus the half. The LCM here would need to be what? LCM of 5 and 2 is what?
10.
10. 5 into 10 would go how many times? 5 into 10? 5 into 10?
2 times.
Use that factor 2 and multiply the numerator. So 2 times 3 would give us what? 6.
6.
2 into 10, how many times? 5. Because 2 5 is 10. Use that factor of 5 and multiply the numerator there. Write our answer here. 5 ones, 5. So now I end up with 6 plus 5. This gives
Equal
me
11.
11 over 10. So this is 7 and 11 tenths. But you see this 11 tenths? I can change this to what? This is
And
an improper fraction. I can change it to a what?
proper fraction.
A mixed number. So 10 can go into 11 one whole time with a remainder of what? 1 over 10. So now we can add our 7 whole plus the 1 whole and 1/10. So I'd end up with now 7 and 1 would give me what? 8. And I would keep the fraction 1/10. So the answer is 8 and 1/10. The answer is not 7 and 4 over 7. So we don't add these together and then add the numerators and then add the denominators to get 3 plus 4 equal what? 7. And the 3 and no. Okay. So
Okay,
this is not correct. That's not how we do it. So this is one way of doing it. Another way of doing it would be to look at it from the point of view of changing the fraction, as it is now, or mixed numbers to improper fractions. So 3 and 3/5. 5 times 3 would be 15. 15 and 3 would give us what? 18 over 5 plus 4 twos would be 8. 8 and 1. This would be 9 over 2. Again, 10. 5 into 10, 2 times. So 2 times the 18 would give us what? 36. Plus 2 into the 10 here would give us 5. And we say 5 nines would give us what? 45. So 45 and 36. Can set that aside. 36 and the 45. 5 and 6 would be 11 carry 1. So we get, okay, my 1 not going. 4 and 3, 7 and 1, 8. So it's 81. This would be, let me switch colors here. 81 over 10. So if it's 81 over 10, 10 can go into 80 8 times, remainder 1 over 10. So both answers are the same. So this one, we work out by dealing with the whole numbers first. And then we work on the fraction part, this part. Work on this part next. Okay? So 3 and the 4 would give you the 7. That's the whole number. And we work that and we put them together. The other way is where we just change or mix numbers to improper fractions over here. And then we work our way down. Either way, you get the same answer. Is that clear?
Yes, sir.
All right. Moving on. Any questions on that one?
No, sir.
Some people prefer to work it this way because you work with smaller numbers. The largest number that I have to work with over here is 11. But look at the largest number I have to work with over here, 81. So if we're not good with the timetable, then we're going to have a bit of a problem, right? So you have 2 different ways you can do it. You can choose it. All right?
Yes, sir.
So let's go to number 5. 684 rounded to the nearest 10. All right, so we have 684. Let's look at this. What is the 4 is in the what place?
100. No, one's place, sir.
Okay, so this is in the ones place. The 8 is in the what place? In the what place?
10, sir.
Tens place. And the 6 is in the
100 place.
hundredths place. Now we're going to round to the nearest 10. That means that we're going to round to this number. So what do I do to find out what the rounding should be? Anybody remembers?
Yes.
Tell me.
No, 500.
First, I identify the number I am rounding, which in this case is 8. Look to the digit that is to the right. This is what?
4.
4. If it is 5 or more, I am rounding up. And if it is 4 or less, I am rounding down. Excuse me a second, please.
See. See. This come better than school though. This more better than this more better than because school and pay your money.
All right, ready again. Somebody wanted to know how to join. So let's continue. So if it is that I have 4 here, is 4 in my rounding up group or my rounding down group?
Rounding down group.
Okay, so the rule says that I'm going to keep the other digits. So I'm going to keep the 6 and the 8 and put 0 there. So 684 when rounded to the nearest 10 becomes 680. See that?
Yes.
All right, so 680.
It was the 8 round up, sir.
All right, so if these are the answers, A, B, C, and D, what is it? 60 tens, 68 tens, 69 tens, or 70 tens?
Sir, B, sir.
Why you say 68 tens? Why you say this?
Sir, because sir, the 0 has no value.
No. 0. If I have this number 68 and I give you this for it, you're gonna tell me that the 0 doesn't make a difference here and has no value?
No, sir. Sir, why I said it was 68 10, sir, because it's the same thing as the one over there that we just round up, sir. So I kind of figured that 680 81 was, sir. Sir, still
I
there,
didn't
this.
I didn't quite get that.
Sir, I was saying, sir, why I said the 68 68 tens was it, sir, because the one that we've just work out, sir, it's the same thing as the first part, sir. The 68, sir, is the same thing as over there. So I kind of think that the 68 over the part that we've just rounded, sir, was the
Yeah.
answer.
All right, let us look at this. What does 60 tens mean? 60 times 10.
600, sir.
Okay, so this is 600. All right. So 68 multiplied by 10 would give me what?
Yes, sir. So, oh,
No, you have to tell me. No, I want you to tell me.
680, sir.
680. Cool. So 69 sets of tens or six. What would I get now?
69.
69. 69 times 10 would give me 69.
No, sir. 690, sir.
690. Okay. And 70 sets of 10 would give me what?
700.
Good. So which one of our answers? Is it the 60 sets of 10?
Sir,
That would
B,
give
sir.
us 600. So this, no, this can't work, right? So the 69 times the 10, that's 690. Oh, this doesn't work. And the 70 sets of 10, that doesn't work either. The one that works would be what? The 68 by 10 to give us 680. So this works. So 68 tens is the same as saying 680. That's all they want to know. Got that? This question was also on the test that we did last week, Friday. And a lot of
Yes.
people got it wrong because they weren't trying to reason it out. Okay? All right. So just in review, 684 rounded to the nearest 10 is actually 680. What this means, remember when we're rounding up, we have a what? An upper 10 in this case and a lower
And
10. All right. So this means that 684 is closer to 680 than it would be to 690.
yes, sir. If it had been 685 now, sir, it would be closer to 90 than the 600. This, sir.
Brilliant, sir. You get it. You get it. It would be closer to 690 than 680 based on the rules of rounding. Excellent, sir.
Okay.
So here we have number 6. We have a problem, subtraction problem, 0.4, and we need to take out 0.163. What do we need to do now?
Sir,
First,
take away, sir. But over the right hand corner.
what do I need to put over here, sir? Do I need to do anything? What do I write down here? Anybody? What
Yes,
do I need
sir.
to write?
A placeholder, sir.
Okay, I need a placeholder here. Then I will say 3 from 0. That can't work. I'll take 1,
And from the 2.
leaving 1. Carry the 1 there. This will make a set of 10. So 3 from the 10 now will leave me with what? 3 from 10?
7.
Okay. 6 from 1, that can't work. I'll take 1 from the 4, leaving with 3. That 1 is a set of 10 plus the 1 there. This will make 11. So 6 from 11 will be what? Call yourself 6 and count till you reach 11.
5, sir.
Okay, so this is 5. And then 1 from 3 will leave me with what?
Sir, 2, sir.
Good. Decimal point and the decimal point, and we put our placeholder for the whole number. So when we have 0.42 and we take from it 0.163, my answer should be what?
0.257.
That's correct. Here we have another decimal question. We have 0.47 plus 100. What should we get when we add those?
Okay, sir. We'll start working it out now. 0, 7. Yes, we are hearing you, TC. Hearing you. Yeah, me, I hear you. Sir, 100.0
Sir, 100.47, sir.
That is correct, sir. So let's go. I'd have to put what here? Place holder.
Placeholder.
So this would be 7 and 0, 7, 4 and 0, 4, decimal point on the decimal point, 0 and 0, 0, care about number 0, 1. So I end up now with what? 100.4, 100.47. Okay, so we need to remember when we are adding decimals that it's what? Column by column, decimal point on the decimal point. Okay, so we have to pay attention to the columns and where the decimal points are. All right.
Yes, sir.
What is the highest common factor of 12 and 84? So highest common factor, I'll put my 12 here. Draw the line.
2.
So 2 can go into this. 6. Come on, 2 into this 6.
3 times, sir.
3 times.
Okay, and 3 into the 3.
1 time, sir.
All right. So now we have 84. Let me switch colors here.
2.
So 2 into the 84 would go how many times?
2 times, sir.
42, and 2 into the 42, because this is even, so I know 2 can go in there. So 2 into the 42 would go how many times?
21 times, sir.
Good. And then what?
Sir, 3, sir.
3 into the 21, how many times?
Sir, 7 times, sir.
All right. And 7 into the 7 would go 1. So let's look. So 12, the prime factors of 12 would be 2 times 2 times 3. And for the 84, the prime factors would be 2 times 2 times 3 times 7. Let's look at what is common. So 2 is common here, 2 is common here, and what? 3 is common.
Sir.
But is 7 common?
No, sir.
So the common factors would be 2, 2, and 3. Those are the prime factors they have in common. And now the highest common factor would be 2 times 2 times 3. So 2 times 2 is 4, and 4 times 3 is 12. The highest common factor would be 12. So 12 can go into 12 one time, and 12 can go into 84. How many times?
3 times.
3 times? 12
Sir,
3s are 30. 12 3s are 36. How many times?
7 times, sir.
See it here, so 12 times is 7. 7 2 is 14, carry the 1. And 7 1, 7 and 1, 8. Okay? So it goes in there 7 times.
Yes, sir.
Why do we need to know the highest common factor? When we are when what?
Sir, when we are putting the number.
When we are reducing. So like we have fractions and we need to reduce, we use the highest common factor. All right?
Yes. Yes.
Okay, so we have number 9, we have a division problem. We have 2,412 and we're going to divide by 6.
Coming, sir.
I'll give you a minute to try it.
Sir, of course. 16, 24. Sir, 402, sir.
402. All right, let's see. So 6 can't go into 2, but 6 can go into 24. How many times?
4 times.
4 times. Hold on. Let us remember, every dog must swim back. So we need to estimate, we need to divide, we need to multiply, subtract, and what? Bring down. Every dog must swim back. All right. So 6 times 4 now would give us what? 24. Subtract, we get 0. Then we're going to bring down the 1. And we're going to say 6 into 1. That can't work. So we add what? 0. And then we bring down the what? The 2. Now 6 into 12 would go how many times?
2 times, sir.
Okay, so 2 times the 6 would give us what? 12. We're going to subtract, we get 0. Now we're going to test. We're going to test it by saying the what? Divisor multiplied by the quotient should give us back the dividend. All right. So we have 402 as the quotient. We're going to multiply by 6. And we're going to see if we get back the quotient. So 6 twos, 12. Right? 2 carry 1. 6 times 0 is 0. Right back the 1. And 6 fours is 24.
Yes, sir.
So we get it back. Once we get it back, once we have checked it and we get it, we know that it is right.
Yes, sir.
All right.
Yes, sir.
So number 10. This is 7. And we're going to take from that 3 3/4. So 7 minus 3 3/4. How we deal with this one? We had some like this in class today.
Flip. No, sir, not keep.
Yes, man.
Sir, keep the
Put a 1 under the 7, sir.
We're gonna change the 7 into a fraction by putting it over 1.
Sir, and right, but the same sign. Flip. Sir, 3. So it should be 4/3, sir.
No. This is a minus sign.
Yes.
Oh, yeah.
Okay. So let's look at
Sir,
what
should
we're
we
gonna
check
do.
improper fraction?
Not
No.
hold on 1 second. Let me see if I had this question right.
Yo, TC, sir, gone. My free time now. Yeah, in the pan hole.
Oh,
Yo, yeah, watch match. Right now, me I watch match on my TV, you know. Yo, me want Boys Stone mash down the place. Yo, one Boys Stone mash the place. Yeah, on TVJ. When me done, me go watch SpongeBob. Sir, come
really?
back. Yeah, yeah. So what wrong with SpongeBob?
Not wrong with it, man. Not wrong with it at all.
Yo, Boys Stone, I go wash up the place. Yeah, watch it TV.
So, Boys Stone a lead right now?
No, then just start play.
Oh. So, you swear if them are going to
Yo, Boys Stone, I bad side you though. Yeah, talk about. Boy, keep out on puppy goal.
What is going on?
Go watch it now.
On the bus. On the bus.
Yo, yeah, David. Go watch it. Or you go watch it before sir come back. Yo!
I'm turn on the TV. No, I'm not turn on the TV. Let me go and see how text me on WhatsApp.
I took on in there too. Me just tell Anna say, sir, start the meeting. Yeah, me see it. Me see how that I keep. Me see every number TC.
Huh?
Me see every number.
Aye.
Sir, come back.
You come back?
Me no know.
Me a text you on WhatsApp right now. You know?
Yeah, me a send me YouTube channel sitting.
Quick.
Subscribe to it and like. Here, me didn't put up one other video special. If you want girl, you watching everything on like me have 5 subscribers, but 1050 likes. Yeah. I joke, man, me have so much likes. Me about 4 or 6.
Well, me take time. Me listen to a voice note.
Aye.
Sanjay,
Shh. Tapping eyes.
at that time. Oh,
Me take
Hi,
time to.
hi guys.
I sir.
All right, hold on a second now.
TC, sir, come.
Fell off a while ago. Okay, so back to the question. So the question, when I check the question is not a division problem, it's a subtraction problem. So we would have to go ahead and take the 3 from the 7, leaving us with 4. And then we'd have 4 minus 3/4. We're going to take 1 from the 4, leaving us with 3. The 1 that we have taken, we're going to change it into a fraction using this denominator. So we're going to get 3 and 4/4. We subtract. We're going to say 3 from the 4 leave us with 1 and keep the denominator. So we have 3 1/4 at the end. And we did some of these in class the other day.
Yes,
All right.
sir.
Sir.
So everybody see that and understand that?
Yes, sir.
Yes.
So let me go through it again. So if I have 7 minus the 3 3/4, let's work on the whole number part first. And I would have what? 3 from the 7, leaving me with
Sir,
4.
I'm not you, sir. Sir, your
You
audio,
hearing me?
sir, your audio is bad, sir.
Okay, so I'm saying that after I take the 3 from the 7, I'll be left with 4.
Okay.
And then I would need to take from that the 3/4. I'm going to
Yes, sir.
change the 4 into 3 whole and 4/4 and take 3/4 from that. So now I'm going to be left with 3, and 3 from the 4 we leave me with 1, and we keep this, the
Yes, sir.
denominator. So we end up
Yes,
with
sir.
3 and
Yes, sir.
1/4. What is the value of the 9 in this number? Hold on. The value of the 9.
Sir, that is what is the reciprocal?
No.
Sir, 10,
The
sir.
9 tens. So what is the
900.
true value?
90, sir.
900.
90, sir.
90. Because this would be
90.
what? Ones, this is tens, this is hundreds, and this would be thousands. So so this is really 3 times 1,000 plus 4 times
100.
100
9
plus
times
9 times 10 plus
1 times 1.
5 times 1. So this is really what? 3,000 plus 400 plus 90 plus 5. So we end up with 3,495. So the 9 here stands for 90. Please remember that this question is testing if we know face value, place value, and what?
And
True
value.
value.
Yes, sir.
What is the reciprocal of 8 and 1/3?
8 and 1.
Sir,
Come in, sir.
sir,
Come in, sir.
2 more seconds.
sir, come in, sir.
Come in, sir.
Too long.
Sir, 20.
Jesus.
Sir.
All right, so we need to change our mixed number to an improper fraction. So 8 times 3 would be
Yes, sir.
24. 24 and 1, 25
25,
over
sir.
3. The reciprocal, we're
And
going to do what?
3
Invert.
over 5.
So this would be equal to 3 over 25.
25.
0.7 divided by 10.
7 divided by 10 equal 7.
10. Yes, sir.
Anybody?
Wait, sir.
Yes, sir.
Answer?
Sir, come in, sir. 7.
10. Sir.
All right, just look at it. When I'm dividing, yes, have an answer.
0. Sir, it's not correct, sir.
Okay. When I'm dividing, I'm going to be moving the decimal point to the left. If this is 10, it means I'm going to be moving the decimal point one place to the left. Now, if the decimal point goes there, it means that it looks like this. 0.07. But I'm going to put a placeholder here so I get 0.07. Is that clear? When you go to high school,
Sir, is that right?
when you go to high school, they're going to tell you that you don't move the decimal point. What you're actually moving will be the digits, right? But for now, for now, we're just going to move the point. It's easier and faster for now, right? So
Yes,
our answer
sir.
again is 0.07.
Yes, sir.
Yes.
Here we have a question. This has to do with sets. We have set A, set B. Which is not an element of either set A or set B?
Sir, it pro. Oh, I'm seeing it now.
Sir, 9.
Very good. So the 9 is not the element, an element of either of these sets. Is that clear?
Yes.
What are the elements in set A?
Sir, 7, 2, 3, and 5.
All right.
5.
What are the elements in set B?
4, 5, and 10.
4, 5, and 6.
So 1 to 2. 2 in there too, you know?
Yes, sir.
Remember that 2 is common to both set A
Yes,
and
sir.
set B.
Set
All right?
A union, set B, sir.
No.
No, not union. That is the intersection.
Yes, sir.
All right.
Intersect.
Let's go over to this one. How many elements are in the union of set A and B?
How many elements are you?
One.
There's 7.
So A union B will be equal to
7, 3, 5, 2. No. 7, 3, 5, 2, 4, 5, and 10, sir.
how many elements?
7, sir.
7.
Ah,
Remember that the 9 is not a part of this union. Okay?
Yes, sir.
yes, sir.
So we can't include it. So 1, 2, 3, 4, 5, 6, and 7. When we have the union, we do not repeat anything that is common to both.
Yes, sir.
Yes, sir.
How can we describe set B? Look at set B. How can we describe set B? 2, we have 2 and 4, 2, 4, 5, and 10. What are those? Are those odd numbers less than 9?
They are factors of 20, sir.
All right, let's test each of these and then we get to that. Are they odd numbers less than 9?
No.
No, sir.
Only 5 is an odd number here, and 10 is greater than 9. So we know that it cannot be A.
Yes, sir. Mark
So
it.
we know say this one not right. Numbers
Yes, sir.
divisible by 3. Okay.
Yes,
2 is
sir.
not divisible by 3. 4 is
Sir.
not divisible by 3. Exactly divisible. 5 is not exactly divisible by 3. 10 is
And
not exact. All right. So we know that it is not B. Factors of 20. 2 can go into 20.
Yes, sir.
4
10.
can go into 20.
Yes, sir.
5 can go into 20. And 10
10,
can.
sir.
All right. It look like it can be this, but I still have to check D.
Yes, sir.
Even numbers less than 5. No, sir. Because 10 is more than 5.
yes, sir.
5 is
Yes,
equal
sir.
to 5. So, no.
Or C.
So
Sir,
our answer
4 is
would
an
be
even
C.
number.
Our
Sir,
answer
4
would
is,
be?
C, sir.
sir, 4 is an even number less than 5, sir.
Yes, but all of it does not make, one section does not make all of it correct.
Okay, sir.
Sir, 20 boxes of pens are a set. Each has 7 pencils. How can you calculate
Okay,
the
now
total
calculate
number
the
of
total
pencils?
number of sets.
So how we answer that one?
Sir, by adding, sir.
Add in.
Yes, sir.
So we're going to add 76 20 times.
No, sir. Multiply, sir.
Okay, so we could say 20 boxes multiplied by 76 pencils, and
Pencils.
we will get the total number of pencils. So we can work that out now. 76 times the 20. We just, since there is 0 here, we'll just put the 0 back, because any number multiplied by 0 will give us 0. Then we'll say 2 times 6 would give us what? 12. Write down our 2 and carry 1. And 2 sevens would be what? 14. 14 and 1 would be 15. So
Sir,
there should be 1,520 pencils in all.
okay.
Sir, that's not a, sir, I learned that a different way, sir. But that
Are
way
you?
is correct, sir.
Tell me.
So you're going to say 0 by the 6 and then the 0 by the 7. And
Yes,
after
sir. That's how I learned.
placeholder, sir. And then you go to the 2, sir. And multiply. So we placeholder. 2 6 is 12. Carry 1.
Plus.
Sir, I prefer your way, sir. It's shorter.
No. It's the same. You're getting the same result, but instead of putting this line of zeros here to add them afterwards, I simply add 1 0 there and continue working.
Yes,
I get the same result. Okay.
yes, sir.
Yes, sir.
So my answer here will be 1,520. All right. Just 3 more to go and we're done.
Yes, sir.
Yes, sir.
Common multiples of 10 and 14.
Sir,
5. I,
Think
sir.
about what it's asking you for.
No, the common multiples of 10, sir. 2, sir. 5, sir. And 10.
All right, let me give you option the answers that they gave. 2, 10, 28, and 70. Common multiple of 10 and 14. Now, remember what a multiple is? A multiple is a result of multiplying two or more numbers. So 10 times 1 is 10, 10 2 is 20, 10 3 is 30, 10 4 is 40, 10 5 is 50, 10 6 is 60, 10 7 is 70, 10 8 80,
10,
10, 9, 90, 10 tens, 100. Now, these are multiples of 10.
Yes,
What
sir.
are the multiples of 14 now?
8,
sir,
8?
2, sir.
No, man.
28,
8. So you have
20.
14 and then what? 28? Because 14 times 2 would be 28.
Yes, sir. And mm,
14 times 3, 42, right? 14 times 4 would give us what? 56. 14 times 5 would give us 70. All right. Four, 14 times what? 14 times 6 would give us 84.
sir, the answer is
14 times 8, 112. We don't need to go any further because we can see a common multiple here of what? 70. So the,
70.
so the common multiple there is what? 70. All right. So there's a difference between common factors and common multiples. Okay. All right. List the prime factors of 24. We did this in class this evening.
Sir,
Yes, sir.
2, sir.
Let's use
Sir.
the factor tree method.
2, sir.
So 2 times what gives us 24?
12,
12.
sir.
All right. So we
2,
can keep our 2, but we break 12 open into what?
2 by 6.
2 by 6. So keep the 2, keep this 2, and we can break 6 into what?
2 by 3.
2 by 3. Now, do you notice that we are down now to just only prime numbers? So 2 is prime, 2 is prime, 2 is prime, and 3 is prime. All right. So this is the factor tree method.
1 is prime number.
Now we can move to the ladder method. So if I have 24,
Sir, 2 into 24.
how many times? And the 2, since 12 is
Into
even, I can use 2 again. So 2 into 12 would go.
6 times, sir.
Okay. 6 is even, so I can use 2 again.
3 times, sir.
3 prime.
And then 3 into 3, 1. So the prime factors of 24 would be 2 and 3.
3, yes,
Sir.
2
2 and 3. I don't need to write back all the 2's in this case when they ask me what the...
4, 2.
I didn't hear that. Go again.
6 can go into 24 and 8 can go into 24, sir. And 12 can go into 24.
Yes,
Yes.
but what? Look at this word here. I'm underlining.
Prime.
Prime. 6 is
Prime.
not prime. 8 is not prime. 12 is not prime. They ask for the what? Prime factors. Remember, prime factor, it has only 2 factors, 1 and itself. So what are the factors of 2? Only 1 can go in there and 2 can go in there. What are the factors of 3? Only 1 can go into 3 and 3 can go into 3. So that makes 2 prime, that makes 3 prime. But look at the number you call 6. 1 can go into 6, 2 can go into 6, 3 can go into 6, and 6 can go into 6. This is not prime. This is what we call composite. Okay?
Yes.
So they see it here, so they ask for what? Prime factors. So 2 and 3 are the prime factors. Now, if we were going to represent that properly, this would be 2 to the third power, 2 to the third power multiplied by 3. Okay?
Yes, sir.
Any questions on that?
No, sir.
Sir.
Last question. How many quarters are in 5 and a half?
Yes, sir.
Let me see if you guys are thinking.
Sir,
You must have full quarter and one.
One,
Full quarter and one.
1.5, sir.
Let me give some more.
and one, sir.
Sir,
Sir,
22.
sir, four quarters in one, sir.
22. Sir, it's 22.
22. All right, so let's go with this and see how we could do this. When we ask how many are in one thing, we're being asked to what? To divide. So this is really saying 5.5 divided by a quarter. So let's go with this. We're going to do what?
keep, change, and flip.
Now it is that we need to what? Keep, we need to change, and we need to flip.
Flip.
All right, so 2 5s will give us what? 10,
10.
10 and 1, 11 over 2. Multiplied, because this is where we're going to change the sign, and we're going to flip the divisor.
4 over
Flip.
1.
4 over 1, right? I'm writing 2. So let's reduce as best as we can. 2 into itself, 1 time, and 2 into
4.
2 into the 4, 2 times. So numerator by numerator now, that would be what? 11 times
11 times
over 1 times 1.
over
11 times 2,
20.
22 divided by 1. Any number divided by 1 remains the same. So I get
same.
22. All right, we got that?
Yes,
Yes, sir.
Yes.
yes, sir.
All right. There's another way of looking at this, If one whole, the one whole here, and the one whole contain 4 quarters, see 1 quarter there, another quarter here, another quarter here. Look at it.
Yes,
If I have 5 of these, it would be what? How many of them?
Sir,
5 times the 4 would give me what? 20. Not true?
yes, sir.
yes,
And
sir.
and a half. Look at a half. This is a half. A half has 2 quarters in there. So it would be 20 plus the 2, giving me what? 22. Understood?
Yes, sir.
All right. So you can reason it out like that, or you can solve it regularly as we do in class. Okay? Either way, we should get to the same answer. All right, guys. That's it for tonight. We did 20 items. So hopefully tomorrow we can do some more. Always
Yes,
take the
sir.
time to practice and remember that mathematics is not magic. Mathematics is logic. Take care and
Yes, sir.
see you in the next episode.
Yes, sir. Bye, sir.
All right, bye.
Sir, these are episodes, sir.
Yes, there. So each time we do one, that's an episode.
Yes.
Okay, sir.
All right, bye.
Yes, sir.
Bye, sir.